Assalamualaikum and hello everyone. It's great to see you all here. My name is Nurul Nazira and my matrix number is A176468. Today, me and my friend Nur Nabiha Amira are here to presenting for Group 12 with our topic Microwave Assisted Thermal Sterilization Food Processing Technology, or we call it as MET. First of all, let me introduce to you my group members. Nazira Afiqah binti Nur Azhari, Aisyah Akila binti Arifin, Yuni Suraya binti Roslin, Nur Armahanis binti Azmi, Murni binti Osman, Nur Nabiha Amira binti Muhammad Supandi, and me, Nurul Nazira binti Abdullah. What is MET's technology and how does it work? Microwave Assisted Thermal Sterilization MET is a new food processing technology that uses long wavelength microwave energy together with heat to sterilize packaged food. This technology has been used widely in the food and beverage industry as it saves time and the process is faster than using conventional methods. MET, which was developed at Washington State University, is also a new food processing technology that uses a combination of pressurized hot water and microwave technology to quickly eliminate pathogen and allow packaged food to be stored at room temperature for up to a year. MET uses a combination of long wavelength microwave energy and pressurized hot water to sterilize food. Packaged food is immersed in pressurized hot water and then heating the food with microwave energy at a frequency of 915 MHz for 10 to 15 minutes. This method eliminates pathogen or microorganisms that may risk the quality of food. Shorter heating time can improve nutrient retention, color, texture, and food flavor.
Okay, next we are going to look for the comparison between METs versus retort method in the process of sterilization. For METs, in contrast, METs uses a combination of long wavelength microwave energy and pressurized hot water to sterilize packaged food. This method eliminates microorganisms and pathogens that may impair the quality of the food. METs also involves quickly immersing packaged food in pressurized hot water and then heating it with microwave energy at a frequency of 915 MHz for 10 to 15 minutes, a fraction of the time required for conventional sterilization methods. For rated method, food was sterilized using the traditional rated method requires manufacturers to place the product into a pressurized cooker, where it is exposed to high temperature of approximately 121 degrees Celsius for up to 1 hour. The process often results in the food becoming damaged from exposure to heat, and consequently, brands frequently use salt, flavor, texture, and color enhancer to compensate for the damage.
The advantages of MET is its significant reduction in thermal processing time, which is 1/4 to 1/10 of conventional processing time. Next, it's greatly improved product visual and sensory appeal, particularly prepared meal containing delicate ingredients. It's also improved nutrient retention and inherently capable of adaptation to continuous type sequential processing, warehousing, transportation, retail sales, storage, and presentation. But METs also have the disadvantages where it will increasing the cost and production due to electrical use for the processing of thermal energy utilization is high, particularly for natural gas. The application of METs technology. It using heat-sensitive food such as egg and dairy product. It's likely to benefit from a sterilization method that requires less processing time. METs has been successfully used to process a number of such products including seafood and pasta product, and according to 915 labs, culinary experts have been using MET's system to create recipes that feature nutrient-rich ingredients which are high in protein, fats, and fiber. MET is especially well suited for this type of food. First, baby foods. Second, vegetable, sauce, greens and rice, and smoothies.
Next, we are going to look up for a case study, which is to determine the shelf life of ready-to-eat macaroni and cheese in high barrier and oxygen scavenger packaging sterilized via microwave-assisted thermal sterilization or MATS. This study was conducted by Center of Excellence for Food Safety supported by USDA and IFA. Microwave-assisted thermal sterilization or MATS offers a shorter processing time than retort process, with similar lethality. This minimizes quality degradations and is less detrimental to package barrier properties. This study also investigated oxygen scavenger packaging and other high-barrier polymer packaging used to extend the shelf life of ready-to-eat thermally sterilized macaroni and cheese. Specifically, physico-chemical quality parameters were determined, including vitamin A and vitamin E, color, instrumental texture, and sensory attributes of macaroni and cheese. So from the studies, there were effects, which is specifically for the thermal processing effects that we could observe from the experiment. Firstly, in the terms of oxygen and water vapor transmission rates, and also nutrients and physico-chemical quality. Although the oxygen transmission rates and water vapor transmission rates of packaging may slightly change during storage, the values obtained just after thermal processing were considered to explain physico-chemical changes in macaroni and cheese during shelf life. For the nutrients and physico-chemical quality, the vitamin E is known for its stability and an increase in content with high temperature processing. In this study, vitamin E increased by 39%. As cooking or baking time increased, vitamin E significantly increased. A short heating time helped release the vitamin E, which is naturally present from its binding sites in tomato. Vitamin A concentration increased by 28% after processing in this study. This may be attributed to the presence of Arabic gum and starch as ingredients in vitamin A palmitate powder. The shear force of macaroni increased significantly after retort processing, while MATS processed macaroni showed a softer texture compared with retort processed macaroni. This was probably because the volumetric heating MATS in a short time at a high temperature softened the texture of macaroni compared with conduction and convection heating of retort for a longer time. So for conclusion, the results of this study demonstrated that thermal sterilization selectively affects the physico-chemical quality and vitamin content of ready-to-eat macaroni and cheese. The color parameters of macaroni and cheese were not affected, while vitamin A and vitamin E increased after MATS and retort processing. The retort process resulted in a higher shear force of authentic macaroni compared with MATS processing. And that's all from our group. Thank you everyone for keeping your eyes on and listening to us. Bye!